Today I'm going to be talking about creating distributable extensions and utilities with Lasso. These utilities in this sense are command line utilities, and this is a new feature of Lasso 9, being able to run Lasso not only in the context of a web server, but also, as you might, a shell script, etc. But this talk is specifically about compiling these utilities natively to native code. Distributable means that the end result can be given to the end user to run on an installation of Lasso 9 without the original source code. We've had some of this to some extent with the Lasso apps. This doesn't cover Lasso apps. This is a couple of different things which are new to Lasso 9. The tools for creating these distributable extensions and utilities are all included in Lasso 9, and the tools can be used free of charge. So the process of creating one of these distributable files is called compiling. So let's take a moment and look at what compiling is. Compiling is a multi-stage process.
Hey, Kyle, I love you, and I'll let you finish in a minute, but I want to say that Chris Corwin had the best presentation here, and I'm just going to
So compiling is a multi-stage process, and it begins with your source code. Lasso will compile any bit of source code that you ask it to run. The source code could be files on disk that Lasso reads in, or it could be code that you have in memory that you give it via process, which everyone's probably familiar with. Regardless of where it comes from, the steps are the same. So the first step is parsing. Parsing means that you take the source code and you move through it one bit at a time, and you assemble, or one character at a time, and you assemble these characters into larger structures in memory. So as you're parsing, for example, you get to quotes and some characters and another quote, and parsing knows that that makes a string literal. Another example would be one, a plus sign, and another one makes a math expression. So if the source code contains any syntax errors, then the process is halted at that point. So Lasso creates structures in memory to represent this code. It looks like a tree, and it's called generally an expression tree. And this tree represents the code that you give it, so it matches the code. The expression tree gets sent to the next step, which is the emitter. Lasso uses LLVM, which is the low-level virtual machine. LLVM is an open source project that allows code to be generated and optimized for a variety of platforms. It provides many tools for helping to write compilers, and that's what we use it for. It's a very active project. I know Apple is heavily involved in it. It's using it for several bits of the Mac OS. I think it does some optimizations on OpenGL code as it executes. So what LLVM generates is assembly code, and assembly code is the code that eventually actually gets executed by the computer. This resulting assembly code is emitted as a .s file. S is the file extension that's standardly used. The next step requires external developer tools. That would be GCC. GCC is free and easy install on all of our supported platforms. On Windows, you would use Microsoft's developer tools, which are free now as well. They haven't always been, but you can get freely available versions of those tools. And so to do this native compilation, either GCC or Microsoft tools are required. So GCC takes the .s file and it generates either a regular native executable that you would run on the command line, or it generates a shared library. A shared library would be .dylib, dylib, or .so on Linux or other Unixes, or a .dll on Windows. So the source code is not required to run any of these results, which is why we say distributable. The resulting executables are platform specific. So you would compile one for Linux, you would compile one for Intel OS X for PPC, or you can, at least on OS X, you can do a universal build. It's one file that will work on either of those processors. So all of these files require an installation of Lasso. This is because they use shared libraries for things like Unicode. Plus there's a bunch of core libraries that we ship with Lasso 9, which is where all of our functionality lies. And so to run any of the distributable files that you've created, you do need an installation of Lasso 9, at least to date. The results of these, and I'm going to get into more detail about what the different types are and how to use them, but the results are yours to distribute as you see fit. We don't have any licensing restrictions on these at all, because they really don't infringe on what we would consider to be the meat and potatoes of Lasso that we make our money off of. However, if they're web related, then the end user would need a regular serial number, or else Lasso is running in developer mode. And this is, that's how Lasso works now. Everybody's familiar with the developer mode, with the time and client IP-based restrictions. So the process of compiling can generate two different types of files. The first I'd like to talk about is a library. A library is a platform-specific shared library. It contains code that you use to extend Lasso. These files are placed in the Lasso libraries folder. In the previous version of Lasso, you used regular .lasso script files, but we're moving to compiled format for all of these files. These files can be named however you want. They can be organized into subfolders. Previous version did have naming conventions, but we don't use those anymore. You can name them whatever you'd like. So these libraries come into play when Lasso is asked to run a method or create a type that it sees doesn't exist. So instead of immediately failing and reporting this as an error, Lasso will look through all the files in the Lasso libraries folder. So for each library that's in that Lasso libraries folder that Lasso hasn't already loaded, I will check to see if that library contains the method that was asked for. So this is what we call dynamic loading. If it doesn't find a match in any of the files, then it does eventually get reported as an error. But if Lasso does find a match, then anything defined in that library gets loaded. And once it does find a match, then Lasso will try and run what you asked it to run to begin with, and probably this time it will succeed. A library can contain many different types, traits, methods. Most of the built-in functionality that we provide with Lasso is applied in these library files. And if you're using the Lasso 9 beta, you can see in the Lasso libraries that there are quite a few files in there for a lot of things that you would find familiar. For instance, the date type is implemented in a file, at least on OS X, called date.dylib. It's date.so on the Linux. Map type, for example, is implemented in a similarly named file. PDF types, all of that stuff, the same.